So what is a closure? Closure is simply the implementation detail of functions having lexical scoping. What is a lexical scope? So in this example, when getApple is called, it creates a new function scope. Now this function scope needs a parent scope. So at this point, JavaScript has two choices. It can either set the green scope or the red scope as the parent scope. What is the green scope? So the green scope is the lexical scope, or where the function is originally defined. And what is the red scope? Red scope is the dynamic scope or the call stack, that is where the function is getting called from. Now JavaScript, just like most languages, chooses the first option and sets the lexical scope as the parent. Now, how does it affect anything? So when getApple tries to access the variable apple, it first looks up in its own function scope. Because it doesn't find it there, it has to now look up in its parent. Because the green scope or the lexical scope is the parent, it looks up there and prints that apple is green apple. But in some languages like Perl and MATLAB, it actually has optional dynamic scoping. So in those cases, it would have looked up in the red scope and printed apple is red apple. So why is dynamic scoping not used by most languages? Well, because it makes it harder to author reliable functions. And it has a lot of implicit contract with the caller. Like in this example, get apple can print either red apple or coconut based on where it is called from. But if you did have used lexical scoping, it would always print the same answer, green apple. If you actually want that dynamic behavior, it's better to pass in arguments explicitly from the caller. However, it has limited use cases. For example, passing in a configuration to nested function calls, or like in React contexts.